Okay, so in the previous videos, whether it was extruding the tiles or whether it was creating erosion from those tiles, we were really manipulating every single part of our landform, whether it was a minuscule amount or whether it was a significant amount. And we looked at different parameters such as slope, elevation, and proximity or distance. In this case, we're going to look at how you can start to filter out both the data and the physical geometry because it's going to create a different outcome. And we're going to even tile this a little bit differently because when we start to filter some of this information out, we still want it to have a nice kind of flush relationship between basically this original kind of smooth surface with the new tiled surface. So it's going to be an interesting kind of hybrid of the existing landform and these new kind of rigid forms. And I'm going to show you just how you can filter out this information looking at the slope, elevation, and the proximity. So in this case, we are going to again take our surface and begin tiling it. Instead of using the lunchbox, we are going to use one of the built-in methods, so utility, isotrim. So I plug that into there. I have to include a domain, which is pretty much like the other ways of creating different tiles in the various directions. Again, I'm going to keep this kind of squared, so I'm going to double the u value for whatever that v is. So I'm going to do expression of x times 2. And that might be a little bit too much. I think those are a little bit small for this. So let's do something closer to the 20 range. And the reason I like this method is you'll see that regardless of the kind of landform type, these tiles stay perfectly flush with our surface versus in the lunchbox it really does start to lose the resolution. So regardless of how you tile it, you still retain that existing detail in it, which is what's going to create some interesting outcomes, like I said. So let's start off by just filtering this information based off of its elevation. So again, we can just manipulate certain elements, whether it's low or high. We could even get more advanced and find an intermediate elevation, but for this we'll just kind of focus on one or the other. So again, I'm going to focus on the elevation, so it's not that it needs the elevation of this geometry, it needs the elevation of the center point. So I'm going to again use the area component to get the center lines. And now I'm going to deconstruct these so I get their z values. And this is what's going to be used to filter our data. So I can turn this off. I really don't even need the points on either. So the way you want to start to filter things is going to sets, list, and we're going to use our dispatch component. This is what's going to actually physically separate things. It's based off of the list or whatever you want to filter. It could be this geometry, it could be the data itself, and those are going to be based off of a certain parameter that you create on your own. Usually whenever you want to separate physical data, it's good to even kind of copy your dispatch and run it again with that same pattern so that you don't have to repeat some steps. And you'll see what I mean in a little bit. So again, we're going to set or define an elevation parameter, which is going to essentially kind of act as our buffer or the delineation in these heights. So I'm going to go to math, go to operations, and in this case, let's look at objects that are of higher elevation. So let's use this larger than component. So again, I'm basing this off of elevation, so these z values. And what this is going to do is look for values or filter values out, whether they're going to have a z value higher or lower than whatever I set. So if I look at kind of these bounds just to get an idea of the highest value is 8.33. So I know 4 is around the middle, so let's just start off with a 4 value. This isn't going to physically do anything yet, but it is going to create these true and false booleans or patterns. So basically what it means is if it's registering as false, it means that that value is less than 4. If it's true, it means that value is greater than 4. And we can understand that a little bit better if I pull up this panel. And we can even do it so it's greater than or equal to as well. So we can see that list items 0 to 5 are false. When I look at list items 0 to 5, these are all less than 4. 6 is greater than 4. 7 is greater than 4. 8 is greater than 4. All these are greater than 4, and so that's why you're seeing them as true. So it's that kind of true and false pattern that this dispatch component works off of. So let's use this as our pattern, and this is where you get to decide what you want to physically separate. In this case, it's this geometry. So this is what goes into the list. That's why it's referred to as a list, because it can really be anything. It could be numeric data or it could be geometry. And you'll see that it doesn't appear to actually do anything, and that's just because the output is showing both objects, whether it's true or false. So A is going to be your true values and B is going to be your false values. And so to kind of visualize that a little bit better, again, I'm looking at surfaces. So I'm going to go to my parameters and grab the surface component and drag that into there and copy and paste it, drag it into there, and I'm going to turn this off. And so this, by highlighting the A or the true, everything that's greater than 4, we can start to see how that looks. If I decrease that, so now it's looking at everything that's either larger than or equal to 3, 2, 1, 0. So this is how you can start to understand this filtering of information. And obviously you have the other side of it as well. So it creates some pretty interesting organization of your data. So let's just stick around 4 for now. And so from here, maybe I just want to manipulate our surface. And again, I can do it based off of that same information as their z value. So this is where you could always copy and paste this. So instead of looking at the surfaces, I want to use the z values themselves. So now I'm only looking at the elevations that are greater than or equal to 4. I've got all that other information that's been filtered out, right? So there's a lot of numbers before 4 that are no longer showing up in the A. They're all in the B. So it's from here that I can kind of follow the same kind of processes as before, where I can use, again, that elevation to affect these items. So in this case, maybe I want to show how it goes from a very solid surface to these kind of wire-framed curves now. So I'm going to go to the curve. So I'm just going to generate a curve from there, and you'll already start to see how this begins to work. So again, I've got my solid, now I've got just this idea of a wireframe. And I'm going to do a couple things. So I want to scale them based off of their elevation, and I also want to, if I'm going to scale these, I need to also filter out their center points as well. So there will often be a case where you have to use multiple dispatches. So now the list item is these center points. So again, I'm looking at center points, so that's what's coming out of here are points. So you can see that whether it's the points or the curves, I'm only looking at those things based off of that same pattern. So the pattern never changes, it's just the list items. And sometimes it's good to actually label these things accordingly. So what's cool is you can right click and say cells, cell points, call this cell elevations or Z values, so it's a little bit shorter, right? And again, we're only going to be looking at the A components from here. What's cool is I could actually even just get rid of this surface here, so I'm literally sticking with that. So again, I want to start to scale these based off of their center points, which are here, based off of their Z values. So again, I want to remap these values. So math, remap, and either minimum and maximum. And again, I'm going to stick with the 0 to 1 so I can use my graph mapper. And in order for this to create the outcome I want things that are really high to have very little scale, so it kind of maintains this wireframe. And things that are lower are going to scale a lot more. So, graph type, Bezier, so again, the lower elevation, so the 4 has been filtered down to a 0, and whatever that highest value was, 8.33 gets filtered down to a 1 or remapped to a 1. So I have to think about that. So if it's high, I want it to, yeah, kind of maintain that scale. So I can just drop it a little bit. And then for this, I can just change that a little bit as well. And you'll see now, when I scale this, so I'm scaling my curves based off of these center points. Right, we can already start to see how that works based off of this different scale factor. All right. I don't really want to see my points anymore. But now I can start to again kind of maybe give myself a little more kind of variation so it's not completely linear. And you'll see that, again, I've just got curves right now. Let me turn off of this for now so I don't have that interfering. But again, I'm going to take this and loft it with that, or create a ruled surface. I'm going to go Surface, Freeform Ruled. I'm creating a ruled surface from these two. And you can see that it's, because of that, we don't see a lot of variation. So I want to, again, kind of increase this a little bit more. And maybe 4 is just too high. What's great about this is that, again, I could say, okay, maybe look at everything that's at 3 or above. I can get as far as maybe I want to add a decimal, so I'm just going to double click, add a value that way, and so now I can get a little more variation. Alright, so again, now maybe it doesn't have to be as have as much of that, so maybe I can even really kind of bump that up. Maybe it's something a little bit closer to this, right? Now we start to get another kind of interesting pattern of this. And what's cool is that, again, these cells are kind of maintaining that smooth condition of the original. So from here now, it's still maintaining those original ones that are back here, So now I can actually begin to bake this information. All right, so I've got those. Again, these are the ones I've filtered out. These are the originals. Let's go ahead and bake that. And you'll see that it's kind of maintains a really smooth comparison. So that's pretty cool, where now again, you're kind of maintaining that existing very organic geometry of the original landform, and then it's slowly transitioning to something a little more rigid. And so again, it's one of those things where you can continue to use this process based off of multiple things. It can be the slope, it can be the proximity to this elevation. Let's just kind of do this one more time based off of the proximity to some drainage lines. So I'm just going to move this guy over a little bit. Show you what I'm referring to. So this part. So again, I'm just going to go ahead and retain this information. So I'm just going to shift all of this over. So this is going to be kind of like my elevation script. This is going to be my proximity. So again, I'll do curve, divide these into a series of points, maybe make it a little more dense. And again, I'm going to base it off the distance with this. So I'm going to go to vector, closest point. I've got these center points. I've got the multiple curves, so I'm just going to go ahead and flatten that. Something to maybe, instead of using this divide, I'm going to actually do curve based off of a distance or length. There's really little difference between the two. But let's try something like 3. So that way all these points are equal distance. And again, I'm going to flatten that. So now I've got these distances. So I can start to, again, use this to filter my information. So instead of it being based off of my z-values, now it's going to be based off of my distances. And again, I can start to filter things out based off of that. And so let's just get an idea of what some of these distances are. So let me go to math, minimum and maximum, and see that there's things between 0 and 29. So again, I'm going to use math. Instead of larger than, I'm going to use smaller than, because it is proximity. So close objects are what we're interested in. And I'm going to use something like, again, 15 is about the middle range. So I'm going to, again, use the smaller than or equal to pattern. Sets, list, dispatch. Again, I'm using this smaller than or smaller than component to create my pattern. The list I can use multiple times. So first I'm going to use my subsurface so we can, again, understand that a little bit better. Again, I'm really only interested in the A values. But again, I'm going to copy and paste it. Turn this off. Turn this off. So now we can see, again, which ones are 15 feet or less to my curves. And this is how we start to, again, begin to filter that. So I kind of like this. I like that there's kind of this interstitial space in between. Maybe it's even a little bit more dramatic. I don't know, I kind of want there to be a little bit more in some of these areas. Let's just add another curve real quick. So I'm going to do show. So look at my surface. I'm going to draw another curve around here. Snap to it. Actually, let's just go ahead and draw one more. And again, I like the idea of them snapping together. So now I can select this curve and these two other ones that I just drew. And I can just say set multiple curves, and now again I'll hide the original surface. Now I can see this a little bit better. Okay, I can a little more happy with this. Yeah, let's try to get, let's see what 5 looks like. Yeah, let's stick with 5 now. Okay, so here's those surfaces again. I've got the ones that I'm not going to affect. And then there's these ones that are going to, again, erode away, and maybe they do a couple other things too. Again, in order to kind of control this, I want to use multiples so that I can still use the center point if needed. And then their distances as well. So I can use that again, like their proximity, to affect these things a little bit more as well. So again, I'm going to take these and I'm going to start to scale these themselves. So let's do scale. It needs their center point, which is this one, I believe. Yep. Right, and then a scale factor. Where again, so we've got our distances, we're going to remap it. Use our graph mapper here, graph type, Bezier. And then again, if it's close, I do want them to actually shrink significantly, and then if they're not, they can kind of retain their shape for the most part. So now I can turn this off so we can start to see it a little bit better now, right? So they start to fracture a little bit more. And again, maybe I want them to even start to change in height or start to move in the Z direction. So I'm going to use this very similar component here, or a similar graph. Except now it's going to be to move them. So the high one is they don't want to move. The further or the closer they are, the more they're going to move. And go to math, multiply, so I can give it a little more variation. Again, I'm just going to move them in the Z direction. And again, let's just do one more thing. Let's show everything, and I just want to lift everything up a little bit. Let's go ahead and hide it. See, I don't want to see all of this either. So now I'm going to take the originals here, preview, I'm going to project them down to the C-plane. So they're all almost there. So let's not have them go down as much. So I want this to be the lowest. Looks good. And from here, I can, again, create a ruled surface from their curves. So I'm going to go parameters, create a curve from both of these ones on the ground plane, as well as the ones that have scaled and changed in elevation. Go to surface, ruled surface. You can see that there's even some issues with that, so I could actually even take these so let's just, that way everything, so I don't have these kind of weird gaps here. So what I'm going to do is, again, copy and paste this, project these down as well. Oops, I'll keep that one on. And then Control-C, Control-V for the original. And also, once again, create a ruled surface between these two. Okay, so I've got that, the ones that have moved, the ones that have projected, so I can basically just go ahead and bake all of that. And let's take a look. All right, that looks pretty cool. So now again, I've kind of got this idea of almost like a canyon-like erosion occurring in those areas. And I just want to, again, kind of make it so it looks okay. So there's some curves that I think I mistakenly baked, so I'm just going to type hide. There we go. So now it looks much smoother again. Right? So it's just a very kind of subtle cracking in some of those areas, and now it starts to kind of exaggerate itself. But yep, so this is again a good way to start to understand how you can begin to filter things so there's a cool transition between a seemingly perfectly flush and smooth surface to these kind of more rigid forms.